Here's a video for Notes 9-1, Introduction to Hypothesis Testing. So the basic idea, this is from the video lesson, the significance test, our goal is to assess the evidence provided by data about some claim concerning a population. So you collect the data, analyze it, and based off of that, you make some type of judgment. So here's a basic idea. An outcome that would rarely happen if a claim were true is good evidence that the claim is false. So here's a concrete example for you. I claim that I make 80% of my free throw shots, okay, but you might think that I make less. So to determine if my claim is true, you're going to have me shoot 100 free throws and I only make 50, which means I made 50% of my shots. So now we have to compare the data that we collected to the original claim. Okay, I made 50% of my shots. This could happen. If I truly make 80% of my shots, in a sample of 100, I could only make 50. However, this is most likely unlikely if my 80% claim were true, right? We would think that I would make closer to 80%. 50% seems pretty low considering I'm saying that I'm claiming that I make 80% of my free throw shots, which kind of indicates that this original claim may be false. So in order to do a significance test, we have to write out what's called our hypotheses. So our hypotheses are always written in terms of the parameter, which means either mu or p. There's two hypotheses, starting with a null hypothesis, which you write as HO. It's usually a statement of no effect, no difference, or no change from historical values. So we usually use an equal sign. However, we can also sometimes... Sorry, my dogs are barking. We could also sometimes use a less than or equal to or greater than or equal to, but an equality is somehow involved in the null hypothesis. But generally, you're going to see just an equal sign in my class. The null hypothesis, we assume true unless we find evidence to reject it. So if we go back here, I make 80% of my free throw shots. The null hypothesis would be P equals 0.8. So here are some examples. Null hypothesis mu equals 67 inches. So in words, that would be the average height of women is 67 inches if mu represents the average height of women. Another one involving proportions, P equals 0.5. So if P represents a proportion of red cards in a deck, this would be the deck of cards has 50% red cards. Here's another example, our null hypothesis, mu m equals mu f. The mean GPA of males and females are equal if mu represents the mean GPA. And then an example of a two-sample proportion, PS equals PJ. The proportion of high school seniors who plan to go to college is equal to the proportion of high school juniors who plan to go to college, if P represents the proportion of students in whichever sample who plan to go to college. Our alternative hypothesis, which we write as HA, is the claim about the population we are trying to find evidence for. So we can use a less than symbol, a greater than symbol, or a not equal to symbol. Okay, so in looking at this, I claim I make 80% of my free throw shots. If you think I'm lying, that I'm over exaggerating, our alternative hypothesis would be P equals less than 0.80. That's what we're trying to find evidence for. So here are some examples. These kind of go along with the previous examples. So the alternative hypothesis to this first hypothesis, null hypothesis, would be mu is greater than 67 inches. The average height of women is greater than 67 inches. The alternative hypothesis maybe to this one could be P does not equal 0.5, meaning the deck of cards does not have 50% red cards. The alternative hypothesis for this one could be mu m does not equal mu f, which means the mean GPA of males and females are not equal. And then the alternative hypothesis maybe for this example is the proportion of seniors, PS, is greater than PJ. The proportion of high school seniors who plan to go to college is greater than the proportion of high school juniors who plan to go to college. So here's an example of writing out a one sample null and alternative hypothesis. It says a company has developed a new deluxe AAA battery that is supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company would like to be convinced that they really do last longer. Based on years of experience, the company knows its regular AAA batteries last for 30 hours of continuous use on average. So this keyword here indicates, and also we don't see any percentages here, indicates that we should be using means for this problem. And the mean that we are talking about is the average length that these batteries last, the lifetime of the new deluxe AAA batteries. So our null hypothesis, we use an equal sign, is mu equals 30 hours. So the mean lifetime of the new AAA batteries is equal to 30 hours. And our alternative is what we're trying to find evidence for. We're trying to find evidence that they last longer, meaning the mean lifetime of the new AAA deluxe batteries is greater than 30 hours. So this is a one sample mean problem. It's one sample because we're only looking at one type of battery. Here's an example of two samples. A website developer suspects that a tool that they use on their website is difficult for senior citizens to use. To do this, they gather data on their website users and define two groups, users 65 and older and users under the age of 65. They then compare the proportion of errors the users in each get. So this is two samples because we have two different groups. We have 65 and older and under the age of 65. So that indicates that we're using two different samples. So that means our null and alternative hypothesis is not going to have a number. Instead, we're going to be comparing the proportion of the two groups. So our null hypothesis is P1 equals P2. So the proportion of errors senior citizens get is equal to the proportion of errors non-senior citizens get. And our alternative hypothesis, it's saying that it's saying it's difficult for senior citizens to use, meaning they would make more errors. So P1 is greater than P2. Proportion of errors senior citizens get is greater than the proportion of errors non-senior citizens get. So how to write your hypothesis? First thing you need to do is identify means or proportions. So in this problem, we know it's about proportions. It doesn't say anything about means. It also says proportion right here. Then you have to figure out if it's a one sample or two sample problem. If it's a one sample problem, you have to figure out what number you are using in your null hypothesis, well, both your null and alternative hypothesis, as well as what symbol should you use in your alternative hypothesis. So looking for keywords such as greater than, longer, less than, shorter, things like that. If it's a two sample problem, you have to define what are your two samples. So in this case, it was the two different groups here. And then just like with a one sample, what symbol should you use in your alternative hypothesis? So in this, it says that this is a little bit trickier, but website is difficult for senior citizens to use. So you would think that they would make more errors, which is why we use a greater than symbol. All right, so just a little bit of practice. Healthcare providers saw that 48% of their members received their flu shot in a recent year. Healthcare provided a new advertising strategy in the following year, and they took a sample of its members to test if the proportion who received their flu shot had changed. What is the correct alternative hypothesis? So remember, your alternative hypothesis is what we're trying to find evidence for, and we're trying to find if the proportion changed. So first of all, we know this is about proportions, so we can eliminate A and B. So looking at these three examples, we know that our alternative hypothesis does not have an equal symbol, so it can't be C. So then we have to decide if it's less than or not equal to. So the key word here is changed, which doesn't indicate a direction, so this one should be E. National Sleep Foundation recommends that teenagers aged 14 to 17 get at least 8 hours of sleep per night. Statistics class at a large high school suspects that students at their school are getting less than 8 hours of sleep on average. To test their theory, they randomly sample 42 of these students and ask them how many hours sleep they get per night. The mean from the sample is X bar equals 7.5 hours. Here's their alternative hypothesis. The average amount of sleep students at their high school get per night is, so we want to know the appropriate ending. So we're looking for keywords here. Well, they suspect that students at their school are getting less than 8 hours. So this one should be less than 8 hours. Remember, in our null, both our null and alternative hypothesis, we should be using the parameter, not the statistic, which is why we're using 8 and not 7.5. 7.5 is our statistic. Quality control engineers testing the battery life of a new smartphone. The company is advertising that the battery lasts 24 hours on a full charge, but the engineer suspects that battery life is actually less than that. They take a random sample of 50 of these phones to see if their average battery life is significantly less than 24 hours. Let mu represent the mean battery life for this population of phones. What is the appropriate null hypothesis for their significance test? So null hypothesis, we know it should be some type of equality, which means automatically we can choose A. Fast food company advertises that pre-cooked weight for its burgers is on average 0.2 kilograms. The company runs a regular quality control test that involves weighing a sample of burgers to see if the burgers are too light or too heavy. If the sample mean weight is significantly different than 0.2 grams, then they recycle the entire batch. What are the appropriate hypotheses for the company's significance test? So just by scanning this, I know that I can eliminate A and B because they're not using the parameter in the null and alternative hypothesis. They should be using mu since this is a problem about means. So looking at these two, the only difference is basically the null and alternative hypotheses are switched. Well, remember your null hypothesis always involves an equality of some sort, which means that D is the correct answer. All right, just a few more examples here, and these are the solutions. So if you're watching this video and you're looking at the solutions and you don't really understand them, let me know and I can go through and explain them to you during office hours.